the hydrate that we've been talking about. Okay? You are going to get, which I don't have in this room right now, but it's in the back, a hydrate, a hydrated salt. Okay? And this hydrated salt, I'm going to show you what it looks like. Stop talking. It is beautiful. Okay, that's what it looks like. It's pretty, right? It's blue. Go figure. Stop talking and listen. Okay? It is a blue salt. It is copper 2 sulfate hydrate. See it right there? Okay. And what your job is going to be is to calculate the percent of water in that copper 2 sulfate hydrate. We've done it a few times. Okay, but you're going to do it with your numbers that you get in lab. Okay? There's going to be a bunch of material that you're going to use. One is called an evaporating dish. It looks like this. There's actually some in here. That's an evaporating dish. Okay? And I'm going to give you some hydrated copper 2 sulfate, and we're going to put it in this lovely little evaporating dish. Okay? When you take that stuff back to your lab table, you need to find out how much water is in that dish. How are you going to do that? What? Subtract what? I just handed you a dish with salt. You have to start measuring things. So what do we need to measure? We need to measure the dish. So we need to have a mass of the evaporating dish. Now sometimes on the Regents, they don't give you the evaporating dish. They'll just give you the hydrated salt and the anhydrous salt. But we're doing it in actual lab, so we're going to have the mass of our dish. And our dish is going to weigh 54 grams. So I walk over to my lab table and I measure the mass of my evaporating dish. Then you're going to come over to me and I'm going to give you some of this lovely blue salt and you're going to go, ooh, ah, isn't it pretty? That's exactly what you're going to say. I know it. Okay? And then what are you going to do?
Touch it.
No. Well, you can eat it, but only once because it will kill you. So don't do that. Right? You're going to find the weight of it. So we're going to find the mass. We are going to heat it up. Okay? So we're going to have the mass of the evaporating dish. I'm going to abbreviate it ED. Evaporating dish. And what's in that evaporating dish? What's the blue stuff?
Salt.
What kind of salt?
Copper 2 sulfate.
The copper 2 sulfate. And what other things besides the salt is in there?
Water.
The H2O. So if I put some in here, let's just put some. Okay? So that's what it's going to look like. Look how pretty that is. Okay? You're going to have the copper 2 sulfate in there. Okay? And you have the mass of your dish. Now your mass of your dish, we know, is 54. This dish and the copper 2 sulfate hydrate. Stop talking. Okay? That blue stuff right there is the hydrate. It's the CuSO4 with the water attached to it. So really what I have here in front of me, thank you, is the salt, the water, and the dish. Do you understand that? Okay? So that thing, we walk over to the balance, and it weighs 146 grams. I'm just giving you numbers. Okay? Now, you're going to heat it up. When you heat it up, what's going to happen to the water? It's going to evaporate. Now, the great thing about copper 2 sulfate is as the water evaporates or vaporizes off of that copper 2 sulfate hydrate, that salt is going to turn colors. It's going to turn into a gray-white color. Pretty cool. That's how you're going to know that the water is leaving. So we're going to take that. We're going to heat it up. Let's pretend we did that. Okay. Now all I have is the gray-white salt in there. You can see a little bit of it right there. Okay. And you're going to measure it after it is entirely evaporated. Now, how are you going to know it's entirely evaporated? I heat it up, the water goes away, then I let it cool off a little bit and I measure it. Then I'm going to heat it up a second time. Even though you think that it's all gone, you're going to heat it up a second time. And you're going to take it off with the little tongs like this, right? You're going to go like this. You're going to lay it on the table. You're going to put it right on the table. And you're going to let it cool off. Then you're going to weigh it again. When you weigh it again, you're going to record that. It's not hot, so I don't really need tongs right now. Be careful. This will get very hot. If the mass doesn't change, you can assume that all of the water is gone. If the mass changes, you need to heat it a third time. You need to make sure that that mass does not change, to make sure all the water is gone. Isaiah is like having a really tough time back there. What's the matter? Your neck hurts. Did you hurt it in gym? Okay. After the mass no longer changes, we have our mass of our evaporating dish and your anhydrous salt. Is it going to weigh more, the same, or less than this number?
Less.
Less. That's good news. So let's say it weighs 112.88 grams. Now, we're done with all of our measurements. Okay, we have the mass of our dish. We have the mass of the dish and the hydrate. We have the mass of the dish and the anhydrate. What is the mass of the water? Which one? Which ones am I subtracting? We're going to subtract these. So somebody with a calculator, give me a number, because I don't have that. I think it's 92. What does that weigh? 146 minus 112.88. Oh, 33.12 grams of water. Can you tell me the mass of the CuSO4? Just the salt. How can I find just the mass of the salt?
Subtract the dish.
From?
The total mass.
Well, which one is the total mass?
The hydrate, the second one.
This one has the water on it. I don't want the water. If I subtract these two, aren't I getting the mass of the whole thing? This is the salt and the water. This is just the dish. So this is the dish. This is the dish and the salt and the water. And this one is the dish and the salt.
You subtract it from that one.
So which two numbers do you want me to subtract to get the mass of the salt?
54 and 112.
So 54 minus 112.
No, 112 minus.
Oh, good. All right. So 112.88 minus 54. Somebody give me that number. 112.88 minus 54. Hello? 112 point, why am I doing this? 58.88 grams of the CuSO4. Okay? We good?
Yes.
You understand?
Yes.
Okay. Now, I want you to find the mole ratio of copper 2 sulfates to H2Os. So I want you to find these numbers, this and this.
All right.
How do I find the mole ratio of this to this? It's exactly what we were doing last period. How many grams of water do I have? 33.12. What do I have to do to get this to be moles?
Divided by total mass.
So moles equals grams over gram formula mass. What's the gram formula mass? 18 grams per mole. What's 33.12 divided by 18? 1.84. All right, that's 1.84 moles of water. What about if I want to find the moles of the salt?
You get the 58.88.
Yep.
And you divide it by the gram formula mass.
Of this, right? So what's the gram formula mass of that?
I don't know.
Well, let's figure it out. Copper, there's 1, it weighs 64. Sulfur, there's 1, it weighs 32. Oxygen, there's 4, they weigh 16. 160 grams per mole. If this is 160 grams per mole, then this is the gram formula mass that goes here. What is that going to give me? What did you say? 0.368 moles of CuSO4. Go ahead, Pinnock. Well, then you're off by a decimal. Make sure that your decimal's in the right place.
Oh, I didn't see it.
That'll do it. Okay, now we have CuSO4 and we have H2O. These numbers right here, 1.84 moles of H2O and 3.368 moles of CuSO4. Is this a nice, neat empirical? No. So how do we get it to be empirical? What are we going to do? No. Divide by the smallest one. So 0.368 and 0.368. What's 3.368 divided by itself? 1 CuSO4 and what's 1.84 divided by 0.368?
4.
Better be 5.
Is it 5? I don't know.
Why are you guessing?
He's trying to do it in his head. It's 5. It's 5. It's 5. He's never book smart. He's really smart. Kevin's just stupid.
5 H2Os. So your mole ratio is 1 to 5. That's what you should get. You should get a 1 to 5 mole ratio for copper 2 sulfate. Okay? All right, that's one part of the lab. Does everybody understand what's happening?
Isn't that the hard part?
It is the hard part. The next thing I wanted you to do is I wanted you to find the percent of water in the CuSO4 pentahydrate, 5 H2Os. How do you find the percent of water in that? Okay, so percent equals part, that's water, over the whole thing times 100.
Yes.
Okay. What was the part that was water? 33.12 grams of water. What's the whole thing weigh?
146. Oh, no.
That has the dish on it. Do you want the dish?
No.
That's just the copper 2 sulfate. I want the whole thing. What is the whole thing going to weigh?
Oh, that. Yeah.
92
Perfect.
grams, and that's the whole thing. So that's going to be 92 grams for the CuSO4 with the water on it. Okay, and then multiply it by 100. So what do you get for a percentage? 36%. You've seen that number before, I hope. Okay?
Oh, shit.
36%. If you don't get 36%, then you either spilled some of your copper 2 sulfate when you were doing the lab, you didn't get all the water out. Okay, that's another reason why you might not get 36%. And so this would be a 0% error because we know we're supposed to get 36%. That's the actual. We did get 36%. What about if this turned out to be 29%?
It'd be a 7% error.
Percent error is going to equal your measured minus your accepted. What was your measured value if you got 29? Let's say this came out to be 29%. Measured is going to be 29. The accepted is always going to be 36 times 100. Take the absolute value of that. So that's going to be 7 divided by 36 times 100. I have no idea what it is. This 29 is the measured value. It's the value you get in the experiment. In this case, we got 36. But let's say you don't get 36. Let's say you get 29 or 30 or 38 or 40 or 50. Okay? That number is this number. Do you understand? Everybody got it? What the lab's going to look like?
Yes.
We are not doing this lab until Friday, and the reason we're not going to do it until Friday is because I wanted to give us a double period to do it so that you have plenty of time to heat up your salt and let it cool off and heat it up again and let it cool off. There's a lot of standing around, a lot of waiting, looking at salt dehydrate, okay? I will remind you of this again when we do the lab. You're going to take at the very end of the lab, that salt is going to be like this gray color. You're going to take it. I'm going to have a beaker up here. You're going to put that salt in the beaker because I want to show you something at the very end. We are putting energy in from the hot plates, right? When you put energy in to the salt, think about barf. What am I doing between the bond between the water and the copper 2 sulfate? Broken, absorbed. I'm putting heat in. It's absorbing the heat from the hot plate. I am breaking this bond. When I break this bond, you can't see it. When I break this bond, the water can now fly away. What's going to happen when I put the water back in? It's going to become blue again. And I'll show you that, okay? So I want to collect all the salts back at the end. You're not going to dump them in the garbage. You'll just dump them into a beaker, and at the end I will show you, okay, how that works. It's pretty fun. Okay, what's that? What do you want a cap on the beaker for?